In the last one, we talked of direct variation. We'll continue and look at inverse variation. At the end of this, we should be able to solve problems involving inverse variation. We will have, as a consequence of this lesson, you distinguish between direct and inverse variation. So inverse variation. So in this kind of variation, as one variable increases, the other variable will decrease. This can be represented in a graph. So this relationship can be represented. Okay, so today my graphs are nice. So we have those two axes. The vertical axis is the y-axis and the horizontal one is the x-axis, and they meet at the origin. So in this, let me just use a different ink to make it interesting. Okay. So in this type of a variation, the graph would look something like this. Okay. Same with, okay, yeah. All right, sorry about that. All right, so we are saying that as one variable increases, the other decreases. The curve is not touching the axis. It's getting closer and closer to meeting the axis, but it does not meet the axis. So what will happen is, if we pick the value, say 1, you'll notice that the y value is slightly larger than the x-axis. Okay, let's pick something like, say, this is a 10. You find that as the x value is increasing, the y value is decreasing. So this is the type of relationship that we will expect from an inverse variation. We move on and talk about notation. So as you have seen, as the value of x increases, the value of y decreases. So how do we write that mathematically? How do we write that? What's happening today? What is happening? Okay. The kind of relationship that we have seen is an inverse variation, and we can express such a variation in notation form as y varies inversely as x. So when you see such kind of notation, they are saying y varies inversely as x. So this implies in equation form as saying y is equal to k over x, where k is greater than 0 and k is the constant of variation. Okay. Constant of variation. We head over to doing some examples. There are 2 examples. We'll start with example 1. Okay. Yes. So given that y varies inversely with x and y is 4 when x is 7, find A, the constant of variation, B, the equation for this situation in the form y is equal to k over x, the value of y if x is 2. So when we look closely there's this statement here, y varies inversely with x. This tells us that this is an inverse variation. In notation form, this is what it will look like. So this implies in equation form that y is equal to k over x. So for part A, we've been asked to find the constant of variation. So we have to make k the subject of the formula. So what's on the right hand side moves to the left hand side. What's on the left hand side moves to the right hand side. So we can write y as y over 1. This is the same thing I've seen in most places, or we've been taught to cross multiply. So we can cross multiply and find, when we cross multiply, you find that k will multiply with 1 and you have k. X will multiply with y and you have x, y. So, but alternatively, I want us to be thinking in terms of what a mathematician should, the skills you should pick up from math. Okay, not this far, I don't want to be this. I want us to think mathematically. I want us to develop skills. Yes. So this stage is where I want us to look at another way in which you should be thinking about this. So this is a stage. So if we also, if there's this method is what we encourage. So when you look at this one, we want to have k. So what you need to do is find the multiplicative inverse. You multiply the multiplicative inverse of 1 over x on both sides. So the multiplicative inverse of 1 over x is x. So you multiply x on this side and x on the other side. So this goes, and what you're going to have is xy. So this is the way we should think about it. But if you feel that the shortest route to getting where you want to get is just cross multiplying, I think that's more like the informal way of doing it. We can do it. So we cross multiply, k by 1 will be k, x by y will be xy, and you will have k is equal to xy. Now, in the question, you've been given y to be equal to 4 and x to be equal to 7. So we substitute those values, and what we have is 4 and a 3. Oh, not a 3. What's happening to me? A 7. Okay, so a 7 there. So when you multiply, you have k being equal to 28. So part B is asking for the equation of this situation in the form y is equal to k. This is a general one. This is a general equation for an inverse variation. So all we have to do now to get the equation for this situation is substitute 28 for the k. So what we'll have is y is equal to 28 over x. And this is the equation for this situation. Part C, the value of y if x is equal to 2. The value of y if x is equal to 2. So we get the equation for this situation and just do a simple substitution. Where there is a 2, where there is an x, we're going to substitute it with a 2. And therefore, our y will be equal to 14. Like that. So let's move on to the second example. Let us move on. Okay, so yes, no. Okay. So the second example has two parts. What I want us to do is that you are going to pause, work it out on your own, then verify your answers with what I'm going to, how I'm going to solve it. You verify those answers. All right. So let's look at part A. Or let's look at the entire question. So if y varies inversely as x, find, using the information in the table, an equation connecting x and y, the values of a and b. In the question, we've already been told that y varies inversely as x. So this situation in math notation will look like this. Y varies inversely as x. Find, using the information in the table, an equation connecting x and y. So y varies inversely as x implies that y is equal to k over x as an equation. This is a general equation. So we need to look at the table of values and use that table of values to find the value of k. We know that the value of k is simply found by cross multiplying, and you have x, y. So k will multiply by 1 and x will multiply by y. So k will be equal to x, y, like that. So what we need to do is to find two values, x and y, in the table. So the only two corresponding values is the first column. X is equal to 0.6 and y is equal to 30. So what this means is that when y is 30, x will be 0.6. So we'll use these two values to find the value of k. So 0.6 multiplied by 30. So when we multiply these two values, so we'll have something like, yes, 36. So we have 18 because we have one decimal place there. So we have 18. So k will be equal to 18. What they are asking us to find is an equation connecting x and y. So where there is a k, we are going to substitute it with an 18. So the equation that is connecting the two will be y is equal to 18 over x. Part B, we need to find the values of a and b. So we have this equation representing this situation. So we'll use this one to find our values. So we'll start with a. y is equal to a in this case, and x, when y is equal to a, x will be equal to 0.9. So we substitute these values in the given equation. Where there is y, we put a. Where there is x, we're going to put 0.9. So we multiply by 10 for, the numerator and the denominator is multiplied by 10, so that we have a whole number in our denominator. So what we're going to have is a will be equal to 29 in 18 is 2. 9 in 0 is 0. So 9 in 9 is 1. So what we have is a 20. So a is 20. Let's try and squeeze in a b somewhere. Okay. Okay. The value of b. The value of b. So when you look at the situation when x is equal to b, when x is equal to b, y will be 9. So we substitute these values in the equation. So where there is y, we put a 9. Where there is x, we are going to put a b. When we cross multiply, because 9 is the same thing as writing it as 9 over 1. When we cross multiply, we have 9 multiplied by b, which will be 9. It will be a 9b. 1 by 18 will just be 18. For us to get a b, we are going to multiply both sides by the multiplicative inverse of 9. So the 9 goes, we'll have b equal to 9 there 1. 9 in 18 is a 2. 2 by 1 will be 2. 2 divided by 1 is 2. Oh, why using the multiplicative inverse? Dude, you're complicating matters. The other way to do it, the one that most of your teachers, but I don't like it because, okay, not most of your teachers. I'm saying what we usually do is we divide both sides by 9. So b will be equal to 2. That is a shortcut. That's a short way of doing things. The mathematical way is what we've been doing previously. This one is a short way of doing it because you know that you're multiplying by the multiplicative inverse on both sides. So it doesn't hurt to think through these things mathematically. So this ends the lesson on inverse variation. As a consequence of this lesson, we have seen that there is a big distinction between direct variation and inverse variation. Hope to see you in the next lessons. Hit the like button and you can subscribe so that you don't miss any other videos that I'll post. Good day or good evening or good afternoon.